Hello and welcome to Using AI and ML to Build Software Faster. Today's webinar is sponsored by Harness and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech, and I'm excited to be your moderator for this special event. Now, before we get to today's great session, we have a few housekeeping items that are going to help you get the most out of this event. First off, we want this to be informative for you, so we encourage any and all questions in the questions box in your webinar control panel. So not only will we have people monitoring your questions during the event, but we'll also have a dedicated Q&A session toward the end of the event where we'll discuss in greater detail some of the top questions that you ask. The Q&A panel is also the place to let us know about any technical issues that you might be experiencing. A browser refresh is going to fix most audio, video, or slide advancement issues. But if that doesn't work, just let us know there in the Q&A and we'll provide further technical assistance. Now, second, in the handout section of your webinar control panel, you'll find that we're offering several resources. I'd especially like to call your attention to several from Harness, including some Harness intelligence documentation, a product roadmap, and a blog about a speed benchmark. So I encourage you to access those resources now, and feel free to share them with your friends and colleagues. Now, third, at the end of this webinar event, we will be awarding a $250 Amazon gift card to one lucky registrant. Of course, you must be in attendance during the live event to qualify for the prize. Official terms and conditions of today's prize drawing can be found in the handout section. Just scroll to the bottom and you'll find the link with the details there. Now, finally, there's one other prize I want to tell you about, and that is a best question prize. So one of the best benefits of an opportunity like this is to ask a question of our expert presenters, and to help encourage those questions, we have this special additional prize for you just to get your fingers moving on the keyboard with your questions. Well, with that, let's get to today's fantastic session. It is my pleasure to introduce you to our presenters today. We have Nofar Bluestein, who's Director of Product for Harness CI, and we have Rutvij Mehta, who's Senior Software Engineer 2 at Harness. So Nofar and Rutvij, welcome. Thanks for being here.
Thank you. It's great to be here. Thanks for the audience for joining us.
Yeah, right. Well, take it away.
All right, sounds good. So let's begin. So today our discussion is using AI and ML to build software faster. We're already introduced. I'm going to skip that slide. And what are we going to cover today, right? So today we're going to discuss about just what a pipeline looks like, and in a generic, typical CI pipeline, what opportunities are there to optimize it? Because I'm sure, just like everybody else, you also want your builds to be faster. So we're going to talk about ways to achieve that. We will also discuss some improvements we can help with where it comes to debugging pipelines failure, and it's going to be we're going to learn about some very exciting things. So first, let's see how a typical software delivery lifecycle looks like. So on the left side, you have a code. Obviously, whatever code provider you're using, right? Your code needs to sit somewhere. And in a typical build process, what happens is that a developer makes a change. The change, basically in the form of commit, right, kicks off, sends an event to your CI provider, which in turn kicks off a build. Once this build starts running, depending on your logic, there is multiple things that typically happen in the build. First of all, the compilation of the code itself. Obviously, you want to make sure that we deliver quality code, so there is testing involved. You want to make sure that the code is not only functional, but also secure, so also security testing is going to be in there. And eventually, once we feel comfortable and confident, right, we're going to publish an artifact, deploy it, so the general population will be able to enjoy the functionality. And in a continuous way, always collect insight, right, and find other ways to improve. So what is the challenge? So this is actually the survey done by GitHub, and they've found, and it completely correlates to what we hear from our customers as well, that 50% of the developers basically say they allocate half of their workday to actually coding, and the rest is spent either by waiting for build time or other meetings or other tasks that developers may be involved in. and get looked into. But this is really an astonishing number, right? This is a very, very expensive resource, the developer time, and 50% of that time is not actually being directed to where we want them, which is, delivering innovation. And 27% of the developers surveyed said that a significant amount of the time is actually spent on waiting for builds to finish. So this is obviously a very high priority, topic for our customers, right? They want to make sure, builds run fast and feedback is delivered quickly to the developers. So and this is not just obviously about, how developer feels about the build time and how much it's not fun, to wait for that. That has a significant, economical impact as well. So one of our customers, Curvy, they're a very innovative company for embedded analytics software. They had a very ambitious goal. They had an internal goal to speed up builds by 50% to meet their internal, OKRs. And they partnered with us, and eventually, through a lot of the optimization methods we will discuss, later today, we're able to accelerate their build time, right? So rather than 90 minutes, which is what they started with, they ended up at like 12 minutes. And again, the benefit is not just time for developers, but also if you're running your builds in infrastructure, right? If you have a Kubernetes cluster that you're using, or maybe run builds in cloud, this also translates to an actual time saving in terms of like infrastructure cost and build minutes as well. So this is just to show that, when optimizing builds, obviously this has a significant impact. So speeding up builds, freeing up engineers to do, other things, right? And spend more times in a more reliable way. In Curvy case, and by the way, this is a published case study, they were able to speed builds up by 8 times, which is quite significant. So let's talk about pipeline bottlenecks and what we see in the field, right? So obviously, one area when customers are struggle with is testing. We cannot emphasize how important testing is, right? To code quality, and it's obviously something that we have to do, and we want to deliver quality software and not having regressions and unhappy customers. So this is a very important part of the build. So we want to ensure, obviously the code quality, and it ends up being a bottleneck. I mean, imagine a typical, CI developer, a typical developer working with CI. They might be building a new feature, make multiple commits a day, or even multiple updates to pull request a day, which kicks off multiple builds a day, and every time they have to run through this testing, right? And obviously wait, till these testing are finished, right? And they have a feedback. So this is an opportunity for optimization. So there are tools out there, and we'll talk about Arne specifically, right? That will help you only run tests that are needed, right? So no reason to run all tests all the time. If you just change the README file, right? Why would you run the whole suite rather than just what's relevant? But also other methodologies like parallelizing, right? Instead of running all the tests serially, right? You can split it into buckets and run them in parallel in order to cut down the build time. There's also a component of flaky flags that sometimes happens, right? And how do you handle these flaky tests that are inconsistent and sometimes fail or build, sometimes does not, and that's also something that is causing delays. Another optimization opportunity is related to caching. So there are multiple types of cachings in CI pipelines. And the problem is that, in older types of, CI solutions where you're running your builds locally, caching wasn't a problem, right? You run your build task, they cache locally, the next time you run, it's already there, the builds are very fast. But what users see when they move to modern solution and start using ephemeral build environments, right, is that the builds actually slow down. And that's often because the challenge of caching. So you get consistent builds, reproducible builds, you get the isolation you want, right, with ephemeral build environments, but you do lose on the caching side because it's a fresh environment, right, and you need to download the dependencies, for example, every time. This is an opportunity, right, to speed up the builds by leveraging caching methodologies, right? And caching not only between pipeline executions, but also across pipeline executions, across all your pipelines if they share similar dependencies, for example. So specifically about caching, there are multiple types of multiple areas where you can optimize. So different types of caching. So one of them I've mentioned briefly is dependencies. So if you use, for example, Java application, right, and you have your POM XML file, it comes with a list of dependencies in it that your project need to download. Another types of caching is Docker layers, right? If you need to package your code into Docker layers, then you will need to download, basically pull all the Docker layers, right, that are in your Docker file in order to build that. So caching these layers can also significantly increase the build time, decrease the build time. And last, build output. So the build tools themselves, whether you're using, for example, Gradle or Maven or Bazel, right? The builds themselves have build tasks that they're executing. And these outputs can also be reused, right? So you can cache all the build tasks outputs and also reuse them in subsequent executions. So to get results that are closer, right, to what you would get if you were just having a local machine and were able to have the cache available for you all the time. Other opportunities to optimize, there are a lot, and we wanted to focus obviously on things that I think would be easier, to achieve, right, and that everybody might be familiar with. One very popular thing is related to conditional execution and skipping builds, right? So this is just going with, we don't have to run everything all the time. Based on specific use cases, you may choose to skip a build altogether. Maybe you need builds that run only for pull requests to main, for example, right, or certain feature branches. So you can avoid, builds altogether. Another thing you can do is, even if the build itself runs, every stage or step, right, could have its own conditions. So maybe based on certain characteristic, for example, you can avoid some steps. For example, maybe you decide that you want to run certain types of tests only for pull request, or maybe only package and create, a Docker image, right, only for pull requests and actual releases rather than for every branch build. So these are things that you'll be able to do. Another thing is related to the cloning itself. So when you use clone, right, you can do a shallow clone to basically reduce the time of the clone rather than cloning your repository with a full history. Right, if you set it, for example, depth to 1, you can significantly reduce the time of the clone. You can also, depending on your needs, you can do things like sparse checkout, git some modules, right, to also get partial code depending on your use cases. So clone there is always opportunity to optimize using clone as well. Make sure, obviously, that you use infrastructure that is suitable to your needs. So machines that are faster obviously can have an impact on your build itself in terms of resources that are available, for example. And across the board, depending on the test that you have, right, you could have opportunities to optimize tests, whether it's tests like I mentioned before, whether it's security scans, SAST, DAST. All these you can look into executing in parallel or executing in a more efficient way, basically. So we talked a little bit about, in general, opportunities to optimization, and I wanted to also show you some of the innovating things that Harness is doing that specifically helps our customers and how we approach these optimizations. So at Harness, we have something that we call Harness Intelligence. And that takes us back to the topic of our discussion today, right? Harness basically employs intelligence across many of our capabilities to help with efficiency. So in the context of CI, we gain benefits in terms of speed. So we have multiple capabilities: test intelligence that allows you to selectively test to selectively run tests only relevant to changes, so you don't have to run everything all the time. And we also have what we call incremental builds, caching-related feature, right? And that touches upon all the cachings that I mentioned earlier, whether it's dependencies caching for your packages, Docker layer caching for your Docker images, or build intelligence for the build tool tasks. And combined, they bring a lot of value, and we will show it in a little bit also in a demo, so you can see that firsthand. So just diving in a little bit further into what each of them specifically means, and you're gonna see these in the demo. So test intelligence basically is our first intelligence feature really in our CI. And from the get-go, we had a vision where we want to bring intelligence, and it was way before AI became what it is today. We're talking about 4 years ago already that we've been working on test intelligence. And with test intelligence, we're basically able, as I mentioned, to run only parts of the test, right? So we generate a call graph, and we know how to associate the changes that users making in their code with the tests that are covering these code changes. And then without compromising, of course, quality, we're able to determine in runtime, okay, this change only correlates to this subset of tests, so we'll only run this. And of course, we're able to speed up, the test cycle this way by saving about, a lot of test runtime. And we support, with that, Java, Python, Ruby, Scala, Kotlin. There are multiple languages that are supported. And you can see here a screenshot. This is like a call graph and our test selection. But again, you'll see this in the demo. Another capability. Oh, before I move on, so just a quick speed test result. So this is something we conducted a couple of years back, actually, for test intelligence, and we just wanted to benchmark ourselves and see how we're doing with this test intelligence and what the impact of this change is. And we took popular open source repositories and we ran them at Harness with another vendor I cannot specify, and with GitHub Action. And we've seen really significant savings. And this is all published. You can go and fork these repositories and set up this pipeline. We have a blog that's explaining everything, and you can see the link here. So you can see that as expected, right? If you don't run all tests, right, and if you make changes that save you, for example, 80% of the tests that you're supposed to run, it obviously reflects in the runtime as well. Regarding dependency and Docker layer caching, so what's beautiful about it is that really Harness does everything for you. So our goal is that you will not have to go and have a complex setup. We've talked to a lot of customers that really just because of how tedious the setup is, never implemented cache. And cache is not a new idea, right? If you can go back 10 years, we had customers, I was talking to customers that were using caching mechanisms. But what's really unique about that is we do that automatically. So it is enabled for your stages, and you don't have to set up everything. As long as your cache is going to be in the default locations, right, default directories, we will just know how to cache and restore it for you at the right time, in your execution. So you don't have to be familiar with caching. You don't have to even remember this is something that you need to do, right? It will just be available for you. And that's true for Docker layer caching as well, right? With all our steps that build and push Docker images, you just get Docker layer caching already enabled for you and giving you performance benefits. And last feature of our intelligence suite is build intelligence. This is currently, as you see, in beta. It's in the works, but it's really unique. So basically, as I mentioned, we are caching the build tasks of your build tools. Currently, it's already in beta for Bazel and Gradle for our cloud customers. Maven is coming soon. And again, our goal is to have a seamless experience. So across the board, we want to make it super easy for our customers to leverage, our intelligence. So really, it will be accessible for everybody because you don't have to, start using, And so you don't have to start, spend a lot of time on configuring and figuring out how these features work. It should just, our goal is to just make it accessible to everybody. And what's also really nice about build intelligence is it's not limited to a specific, programming language, right? As long as your build tool is supported, you can just use build intelligence, right? So even if it's a C++, Objective-C, Java, as long as Gradle, Bazel, or Maven, right, can run these build tasks, you could leverage that as well. So it has a wide impact on organizations. One more thing we have, not aimed at speeding up the builds like all the other features we talked about, but actually to make troubleshooting easy. So the builds run, maybe they're super optimized, but sometimes, of course, errors do happen. And there are a bunch of types of failures that can be in a build process, right? Related to test failures, could be authentication failures. Maybe you put a wrong URL in the API, call. Tools that are not found in the machines, builds to errors itself related to code changes, right? So all these are typical errors that customers see, in builds. And what we have is something that we call IDA, AI Developer Assistance. And one of its capabilities is to troubleshoot builds, and I'll demo that shortly as well. But basically, we leverage Gen AI to find the root cause analysis. So we go beyond, surfacing the error to the user, but actually look at these logs, run it through an AI model, and make sure, we direct our customers, right? What's the best way to proceed? What's the remediation suggestion is, just to also cut down the time it takes to troubleshoot, right? And identify the root cause of an issue. So now it's demo time, and I will pass it on to our root widget engineer on the CI team that have worked on these amazing features, and he'll demo them to you. Go ahead, root widget.
Great. Thank you so much, Nofa. I'll start with sharing my screen. So I have these two pipelines which users normally have in their CI world. So I've taken up two open source repositories so that people have context and they can try this out themselves. So the first one is a PR checks pipeline where the developers raise a PR, and once everything looks good, the PR gets merged. So we are running this on our Harness cloud, and we are using our test step, which is powered by test intelligence. And we have also enabled our build intelligence on this particular repository. So with this flag, we'll be able to cache all the build outputs. So let's go over and raise a PR. So I'll just make a small change here and raise a PR. So what this will do is this will run two executions, one in Harness and one in GitHub Actions. We have the PR checks set up like that. Okay, so it's running in Harness and GitHub Actions. So while this is running, I'll just go over the previous executions. So how you set up test intelligence is when you first create a PR, Harness figures out the call graph and all the relations between all the classes. And once you merge the first PR, now Harness has all the information about your repository as far as the relation between all the classes go. So any subsequent PRs, we know what the files have changed, and we already have the relation between all the classes. So we figure out what are the tests which are relevant to your file changes. So, for example, so here we did a file change. We only have one file changed over here. And if you look here, Harness selected a subset of test. I'll go over the test tab. So out of the 12,000 tests which Harness detected in the previous execution, which was the first one, we only selected 112. And while this is executing, I'll show you the first execution. So Harness figured out that there are 12,000 tests, and since this is the first run, we run all the 12,000. So this is why it took 12 and a half minutes. And since this is running in Harness hosted, which is a very powerful compute, we are still seeing very good results even when it's a full run. And now let's go over the execution. So if you notice here, we have enabled build cache as well here. So if I look for a string called from cache, so for running any test, we need uh, to build the module first, right? So all that modules which are dependent on which the test is dependent on, that's need to be built anyway. So test intelligence will only help you select the test which needs to be run, but the building part still needs to be done. So how build cache helps is the previous build outputs were already there, and those did not change when we made this change. So now, since we are doing an incremental build, we are only building what's new, and all the previous build outputs we directly download from the cache, and that's what you see it here, and the execution is even finished. And if we go here, we have the parallel execution which is running. So we'll wait until this finishes. And let's go over the other execution. So this is a different pipeline which users might have in their CI world, which is once I have merged all my changes, I want to test it and just push it as an artifact, which can be deployed later. So this has three features enabled from our intelligence stack. So the first one is cache intelligence. So here what we do is we save and restore the dependency cache which is related to your project, and there's no configuration required. We figure out what dependencies need to be cached, and it depends on your build tool. Now, going over the other intelligence features, this one we have already gone over, which is test intelligence, and there's no additional configuration required. You clone your repository and just whatever test you want to run, and Harness does the magic for you. And this is the other step, which is Docker build and push. So notice that we have this flag enabled, which is Docker layer caching. So what this does is every layer in the Docker needs to be built. Now, let's say, and this is sequential. So let's say you change something on the very last layer. So you don't need to build all the layers from 1 to n. You just need to build the nth layer, and everything from 1 to n minus 1 should already be there because you already built it before. So what Harness does is, in the first one, we we cache all the layer outputs, and we store it in our backend storage. And when you have a subsequent run, we figure out that there is only one layer which has changed, so we download all the caches for the previous ones and we run it. So I'll just go over a sample execution. So this is the first execution where we have the test which selected all the tests because this was a full run, which takes around 2 minutes and 13 seconds. And then there's a build and push. This takes around 3 minutes. And what I did was I raised another PR here with a small change. So we can see the change here. So here I changed the test file, and you see our cache intelligence. So we restored all the dependency caches which we could, and we ran the test. And if you notice here, Harness selected a subset of test. So now what we have done is, out of the 382 tests, we have selected 52. So Harness knows only 52 need to be done. So we run them. And now coming to Docker layer caching, in my Docker layers, not a lot has changed. So most of the layers are cached over here. So we need not build all of this. So we have saved all the time which would have been taken to build all of these layers. And the final step is we also save any dependency cache. Let's say you add a new dependency. So we need to store it for the following executions. So we do that in this last step. Now, let's see if the actions have completed. You're still waiting. It takes around 15 to 16 minutes to complete. And yeah, back to you, Nofar.
Yeah, thank you, Rutwich. That was a great demo. I hope it made it clear how powerful these optimizations are, and how quickly builds can run once we optimize things with caching and test intelligence. So the last thing I want to show you today, the last demo, is related to IDA, AI Developer Assistance. And as I mentioned, there are multiple things that IDA can do. One of them is to help with the troubleshooting of the builds. So I'm going to start sharing my screen now. And what you see here basically is a failed build. So I have a very simple, Python application, and I have a pipeline that is basically running on our cloud as well, and is executing, install the requirements and run some tests. And if I look at the last executions, I can see that the last execution has failed. And what I see here on the right side is an Ask IDA button. So basically that will bring up AI assistance. And it took for a second, right, to parse the result, but then it tells me what is wrong. So in my case, rightfully so, it pointed me out to me having a missing import. And not only that, also told me how to remediate it, right? So I can take this right now. I can go back, to my code. I can add this import, right? That is being used in this function here, and commit, and we will see this build automatically being triggered, right? Because I've performed a commit. If I go back to my executions, it's quite a short execution. In a minute or so, we're going to be able to see it finishes successfully now that this error is gone. So as I mentioned, it can help with the different type of build errors, but IDA is not really limited to troubleshooting executions. This is what we've focused on today. But it has a lot of additional functionality. For example, we have dashboards in the product, and rather than customers having to write complicated dashboard queries, they can perform, just write what they need in natural languages, and HIDA will generate the required dashboards for them. We have enhancement related to policy generations, right? So at Harness, we have open policy agents, policy evaluations across the board, across the platform. Sometimes, it can be a bit tricky to write the right policy. It has a very particular, language, right, format that you need to use for this open policy. So in a similar way, we have natural language to help you generate this as well. So you can see this build, finished successfully, right, after IDA helped me to troubleshoot. And obviously, the potential. I mean, you're all aware, right? What we see what's going on with the world now with the rise of AI, and harnesses consistently, and since the beginning of CI, really have been looking to ways, to optimize further. So that was it for our demo today. And I'll go back to the deck. And next on our agenda is a Q&A. So I'm going to look at our Q&A panel and see what questions we got from the audience. And there's still time. If you'd like to add additional questions, please go ahead and do so. So Mutwij, I think the first question is for you. One question is, do we need to structure the Docker file a certain way to properly use Docker layer caching? Is there best practices or recommended way to do it?
Yes, there is. So how Dockerfile works is it runs the layers serially. It builds the layers serially. So if anything has changed with respect to that layer, then Docker will build that particular layer and everything after it. So we try to keep the layers which change very often to the bottom and which change rarely to the very top. So for example, let's say I am adding some dependencies and I'm installing some dependencies in the base image of the Docker file. So that will not change with every PR which the developers have. So that can come at the very top, Now, developer, when they change any file, let's say in the source code, I need not install all those dependencies again. It will all come from cache. So the way to think about it is the more frequent the changes are, the towards the bottom the layer has to be. And yeah, there are some unavoidable cases where you have to keep the layers in a certain way. So there are some best practices for that as well. So let's say for node projects, you can copy the node dependency file first. You can cache that, and then you can copy your source code. So this way, any changes you make to the source code, your dependency is already cached. So like these are some of the best practices which you can do. And obviously there is a lot more on harness documentation as well as Docker documentation for the Docker layer caching.
All right, thank you, Twitch. Another technical question about caching capabilities. How does build caching work? Are you using cache keys? How do you manage the cache automatically?
Right. So for build cache, let's take an example of Gradle. So every build tool works differently, but let's take an example of Gradle. So Gradle has a concept of tasks, and every task has an input and an output. So let's say there is a task and the task has not changed. The input has also not changed. So and this input also is a function of the file system. So if nothing has changed in the file system as well for that particular task, the output is going to be the same. So what we do is, there's a hash of all of these, the tasks, the inputs, the outputs. So Gradle will create a key out of it, and Harness has a distributed storage which we run on our backend. So with this particular key, we'll upload these blobs with the key and the value as the blob itself. And whenever Gradle figures out that okay, this is the same task, this is the input, and this is the expect, and I want the output. So it creates the cache key, asks for the blob. We have the blob, we give it to Gradle, and the Gradle will just save from cache.
All right, thank you. I'll take the next question. So we're asked, what metrics do you measure to see if pipelines are optimized and efficiency is improved? So we talk to a lot of customers, right? And I think that generally what customers are looking for, obviously, is build time, right? We've seen it also in the demos today. So build time is one component. But they're looking at other metrics as well. So first of all, they're looking at infrastructure costs. I kind of mentioned it earlier on the demo. So whether you use a cloud provider to run your builds on the cloud, or maybe you self host, your build environment. Unless you have physical machines already, to run on. Typically, there's some infrastructure provider, involved. Maybe you have a cluster on, Amazon or Google or something like that, or you're just using, for a cloud provider, right? And then your builds run for, and you pay per minute, right, of the build run. So that's another metrics that customers are looking into, the infrastructure cost or the build minutes cost, but also measuring efficiency in terms of how many people needs to be involved in the operations. And this is something, for example, we have a lot of customers that are moving from Jenkins, right? It is not a modern solution. And customers are reporting that, people are spending a lot of time on maintenance, right? You have a Jenkins master. I don't know if you've heard, the term Jenkinstein, but these things can bloat, right, and become inconsistent and unstable. And eventually, there are people that are attached to making sure this works, right? So if you have an unstable environment, a lot of or very complicated, pipelines that only a few people can even understand and troubleshoot, right? It just adds overhead. And another metric, that our customer are looking for is the time to resolution. Time engineers, spend on that. How many people needs, to be on the release team? How many people need to maintain infrastructure for the tools, right? These are all things that they measure as well. We run builds on-prem, not in the cloud. Where will the cache be stored? So I can answer that as well. So from a perspective of experience, it was really important for us that customers will get the same experience. So we have on cloud customers that running on Hans Cloud, but we also have a lot of customers running in their own Kubernetes cluster, VMs, or something like that, or locally. And we made it easy for customers basically to provide their own storage, right? So a customer can give us, S3 compatible S3 bucket or an S3 compatible bucket. Give us in the central location, right? Define, the authentication method, and from that point, the experience is exactly the same. So they will not have to build that logic into the pipeline. They'll have the same checkbox. So it's only a matter of when it runs in the cloud, we do everything behind the scenes, right? You don't need to be concerned with anything. But even if you run your build yourself, um, still very easy to do. You just set it up once in a central location with the authentication we need, and everything else just works seamlessly like it is in the cloud. And I think we have one last question here. What other strategies we can use to speed up testing or the build phase? Ludwig, would you like to respond to that?
Yeah, definitely. So yeah, as far as uh, the runtime of the execution goes, Harness has pretty much implemented all the flavors which they could be for a particular build tool. So, starting from building the project, we have dependency caching, which will download all your dependencies. Then we have build caching, which will uh, cache all your build outputs. And now we have test intelligence. So what test intelligence we do is, after you've built your project, we need to figure out what test to be run. So TI will do that. And in the end, when you publish the Docker layers, when you publish the Docker image, we have caching over there as well. So all of these are very good when we have a happy path. When the pipelines succeed, everything is good. But the real pain point for developers, apart from these caching mechanisms, is actually flaky test. So let's say, for example, we have a test which is successful 1 out of 3 times, and the developers always have to rerun. So that is one of the pain points, and Harness is working on improving that experience in flagging these tests, and also making it clear to the developers that this is a test you should look for, and you should fix it, because it would block other developers.
Another item, by the way, we're working on is another ML-based, feature to run all types of tests. So even in integration tests, functional tests, UI testing, right? We're gonna keep investing in optimization to make sure also you only run the test that makes sense, but across a even broader set of tools and programming languages. I've mentioned a few more optimization. It's not always just features, right? Even things that are basic, like using parallelism. Sometimes this is overlooked. So going back to your pipeline and seeing you have multiple steps, but actually these two can be parallelized, and it doesn't impact the order. It doesn't have to have the dependency. So even just by looking at your own pipelines and seeing if you really have to execute everything all the time and implement some conditions, that can be another way to optimize the pipeline.
Yeah, I would also like to know for give some metrics on how we are dog fooding these features.
Sure. Go
Yeah.
ahead.
So we have a monolith in our we have not a monolith but a monorepo, where we used to run all the tests. So we have close to 30,000 tests, and it took around 90 minutes to run all of these tests. And this is, I'm talking about with parallelism 10. So imagine if we had one stage, what would have had happened. So with parallelism 10, we divide all those 30,000 tests into 10 buckets, and that's 3,000 per stage. So now with these 10 stages after parallelism, it used to take 90 minutes for a full run. And let's say a developer changes anything, and they have to run all the tests, it takes 90 minutes for them to see even if there is a failure because of their changes or not. So that's when TI came in. So TI helped to reduce the test times by a lot. So from 90 minutes we directly went to 40 minutes, and this is the average time which now the developers have to wait for to see any execution. This is a mix of full runs and runs where we run hardly any test. So the time actually ranges from anywhere from 15 minutes to 90 minutes, but the average is around 40 minutes. Now we introduced build cache. It was not a harness build cache. We introduced a cache backend which was supported for Bazel, and it was a very huge bottleneck for us because there is only and it was a single point of failure. So that's when we introduced harness cache backend, which supports Bazel, and without TI, just the build cache, we went from 90 minutes to 65 minutes, and this is without TI. So now what we did was, eventual goal was to have TI and build cache both. So that's what we did. So now our average build times have gone down to 25 minutes. So if you see per developer, we are saving 90 from 90 minutes to 25 minutes. So, and this is across 10 stages. And if you compute the cost of it, this is actually costing the company as well. So that's when we save the dollars as well.
So yeah, a lot of obviously, I mean, we're building tools, right, for DevOps. But as a startup company, right, we use everything ourselves, and a lot of these features just came from our internal necessity, and now we optimize our own processes and get to a point where we get what we need out of our builds and deployment tools. So that's all for the question. Thank you, everybody. Scott, I'll move it back to you. Go ahead.
Okay. Yeah, sounds great. Thanks, Nafar and Rudvij. Great presentation, great demo, and thanks for all the insights in the Q&A. Really appreciate your time today.
Thank you.
Okay, and I'm going to leave this this slide up here that has the QR code if you want to scan to get started. Also, just a quick reminder that there are several items in the handouts that you can still grab for the next minute or so. We've got that. There's the roadmap. There's some documentation and also some information on a benchmark. Great resources there, and you can still grab those. And before we wrap up, we do have one more piece of business. It's the Amazon gift card prize drawing. And the winner of that $250 Amazon gift card today is Praveen Cheka from Georgia. So congratulations to Praveen Cheka. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank Harness for making this event possible. Thanks as always for attending and for your great questions. That's going to conclude today's event. Have a fantastic rest of your day.